Okay, what's the answer to this clicker quiz question? The correct answer is this one right here. Y sub A, the vapor mole fraction. Why is this? Let me draw our PZ phase diagram. Never quite looks as nice as I'd like it to. Remember that on this side, we've got the vapor pressure of pure B, but on this side we have the vapor pressure of pure A. And the question says that pure A vapor pressure is lower than for pure B. So we've got a different sort of a plot than we've seen before. I kind of threw you a little bit of a curveball here. There's our liquid line, then here's our vapor line, something like that. Okay? So if I draw a tie line for P total, here's P total, then that means that Z is going to exist somewhere in there. So there's Z sub A, and then here's going to be X sub A, and then here's going to be Y sub A. Notice that it's Y sub A that is the lowest value, and that's why that's the correct answer. Next, I want to help you understand why distillations work. So if you like organic chemistry, if you like synthesis, extractions, then you probably use distillations with some frequency. And here we're going to explain the physical chemistry perspective for why distillations work. So to start, I'm going to draw you a new kind of diagram. Now, don't get confused because this is not a PZ phase diagram. This is something else. In this case, we're actually going to plot the boiling temperature. And down here, I'm going to write the total mole fraction of substance A. Okay, I'm going to draw a couple of points here. One point at the spot where the system has a 0 total mole fraction of A. This is going to be the boiling point of pure B. And then over here, I'm going to draw a different point with pure A, and this is going to be the boiling temperature of pure A. Now, with a plot like this, what we will see is that I'm going to use this blue color to represent a curve of XA, which is, remember, the liquid. So what this means is that as we increase XA, then the boiling point of the mixture is going to shift in a way that this curve describes. Then similarly, if we were to plot how YA changed the boiling temperature, we would see another curve that looked something like this. So this may be a little bit confusing, so I want to help you think about this. What this means is that if a mixture has some boiling point TB, and maybe we can say that that's that spot right there, then the X sub A and Y sub A of that mixture could be found. And that would be like taking this particular TB and that would be our X sub A and our Y sub A. Like so. So how does this help explain distillations? Well, in order to explain distillations, I'm going to go ahead and draw an exact copy, more or less, of this plot right up here. Okay, so I've recreated that plot up above, and I want to go through the process of distillation. let's start with a mixture of liquid mole fraction XA1. So it's the liquid mole fraction at the first step. Okay, step one is to start boiling that mixture. What's that going to do? That is going to give a vapor mole fraction that corresponds to what this plot here on the left says. So that means if we have a particular XA1, then as soon as we start boiling that thing, then the vapor above that boiling mixture is going to be YA1. Okay? So then step two is going to be direct that vapor to a new container to condense. And then once it condenses, then we're going to have a new mixture, and we'll say that the liquid mole fraction of A for that new mixture is going to be whatever A was in that vapor, because we just took that pure vapor and condensed it. So that is equivalent to drawing a straight vertical line down to a new spot and calling that XA2, like so. And then the final step is that we just repeat. So then what we would get is we'd get a new tie line going to a YA2, and then we would just keep going on, and we get an interesting sort of little zigzag pattern like that until in the end we'll have a liquid mole fraction of A after an n number of steps of that distillation, and that's going to be approximately equal to 1. And that is going to be just pure substance A. And that's the point of distillation. It's to extract a pure substance out of a mixture. Okay, now the last thing I want to leave you with is how are we going to think about distillation in non-ideal mixtures? And this isn't something I had you read about, but I want to touch on it because it is included in some ACS exams. And I know we're not taking an ACS exam this particular year, but you may go to graduate school and have to take an ACS entrance exam or something like that. So what I'm going to do then is draw out a couple of diagrams similarly to what I did on the last slide, where we've got the boiling temperature on each of these slides, and then we have the mole fraction of each of them as well. So for this one, these are going to be strong AB interactions, and these are going to be weak AB interactions. So both of these are going to be non-ideal solutions. We're going to have a boiling point of the two different components. We'll start with the vapor. So for systems that have strong AB interactions, the vapor is going to curve like that. And then the liquid is going to curve in an even stranger way. It's going to come out like this, come up like this, touch, and then come down and go like that. Weird, huh? Now for the weak interactions, the liquid state is going to curve something like this, and then the vapor is going to look something like this. So again, we see a couple of these very weird shapes. And what that means is that if you try to do a distillation on one of these, say you have a particular starting XA like that, then by doing a distillation, you'll get the zigzag lines that look like that depending on where you start the particular mole fraction. So you will get to these pure endpoints. And this is called a maximum boiling azeotrope, because its boiling point has a maximum right up here like this. And in contrast, this one is called a minimum boiling azeotrope. And the trouble with the minimum boiling azeotrope, at least, is if you start with a particular mole fraction and you begin doing distillations, you see that as you zigzag, the best you could ever hope to get is that point right there, which is not the pure substance. So if you attempt to do distillations on this type of azeotrope, it's not going to succeed.